Tesla has lost its position as the world's biggest seller of electric vehicles. The Chinese car maker BYD is now in top spot after its sales rose by nearly 28% last year to 2.2 million.
Tesla just built something more powerful than anyone expected. And the strangest part is that almost nobody noticed. It is not a new car. It is not a bigger battery. It is one small piece of hardware so far ahead of the field that the engineers who tore it apart went quiet, because it breaks the one rule the entire auto industry agreed could never be broken. It out-accelerates machines costing 10 times more, runs cooler and cleaner than anything in its class, and may take rivals close to a decade just to copy. So, how did Tesla actually pull it off?
We make the fastest cars that you can buy for the money, whether they're electric or gas.
The underdog. Nobody feared. To understand why a single piece of hardware could make seasoned engineers go quiet, you have to rewind to a version of this story almost everyone has forgotten. Because for years, nobody in the industry believed Tesla would be the one to build it. For more than a decade, the world's biggest car companies were locked in a fight many believed would decide the future of transportation forever. Electric vehicles did not just introduce a new kind of car, they changed the direction of the entire global auto industry. And one company kept appearing at the front of that race: Tesla.
Has America lost the race to make electric vehicles? Tesla is no longer the world's top seller of electric cars.
But here is the part most people forget. In the beginning, almost no one thought Tesla would stay there for long. The company looked ambitious, innovative, exciting, and also fragile. Next to giants like Ford Motor Company, General Motors, Toyota Motor Corporation, and Volkswagen Group, Tesla seemed small and inexperienced. Those legacy companies had spent generations building enormous factories, mastering precision engineering, and stitching together worldwide production networks. They had survived oil shocks, recessions, and a century of competition. The smart money said it was only a matter of time before they woke up, turned their massive scale toward electric cars, and pushed the upstart aside the way they had pushed aside every newcomer before it. And for a while, it genuinely looked like they would. Stay with me, because this is where the story flips. The competition actually improved. Electric cars from rival brands became more stylish, more reliable, more practical for daily life, and battery performance climbed faster than many had predicted. Elon Musk kept talking about the bigger picture: a fully sustainable energy economy built on solar, wind, stationary battery packs, and electric vehicles. But on the showroom floor, the gap was closing. Some analysts began openly forecasting that Tesla's advantage would vanish. The narrative wrote itself. The underdog had its moment, and now the giants would take the road back. Then something unexpected happened. Tesla introduced a breakthrough that quietly changed the air pressure inside the entire industry. Not a new car design, not a bigger battery, not a software update, a motor. And that brings us back to Sandy Munro, hands frozen over his bench. He was no longer looking at a company that was merely leading. He was looking at proof that Tesla had stepped onto ground most rivals could not currently reach. The most frightening part was not how powerful or efficient the thing was. It was how hard it would be to copy. Some analysts have suggested matching it could take rivals close to a decade, and by then, Tesla would already be somewhere else.
In this part of the world, Southeast Asia is a huge market for BYD, and in case you didn't know what BYD stands for, it's actually Build Your Dreams.
The pressure inside. Before we go further, one question matters as much as the motor itself. Why now? Why would Tesla of all moments choose this exact one to reveal something this disruptive? The answer is uncomfortable, and it begins with a truck almost nobody seems to be buying. Here is the part most people miss. Tesla needed this breakthrough, and it needed it now. The Cybertruck, once sold to the world as the future of transportation, had quietly become a problem. After years of hype and global attention, sales fell far below what Tesla expected. The truck that was supposed to rule American driveways became one of the most talked about disappointments in the company's history. And the numbers tell an awkward story. According to reports, the situation grew so difficult that nearly 1 out of every 5 Cybertrucks registered during one quarter went to companies connected to Musk himself, including SpaceX and the artificial intelligence venture xAI. Internal registrations were propping up the figures. Recalls were chipping away at confidence. And in a market where buyers suddenly had a dozen electric options from a dozen different brands, the truck that was supposed to be untouchable was suddenly just one more choice on a crowded lot. Tesla's loudest product was not pulling its weight, and everyone inside the building could feel it. That matters more than it sounds. Tesla's whole reputation rests on the idea that anything it touches reshapes the category. The Cybertruck was supposed to be proof. Instead, it became a reminder that even Tesla can swing and miss, and Musk knew it. The company built on inevitability suddenly looked vulnerable, and that is the strange tension running underneath this whole story. While the headlines were busy declaring the Cybertruck a flop and writing Tesla's comeback obituary, the thing that actually mattered was not on a stage at all. It was sitting on a bench in pieces, the way Sandy Munro found it. The public was watching the truck stumble. Almost no one was watching the motor. And the motor was the part that was about to make every one of those obituaries look foolish. So Musk needed something that could not be argued with. Not a styling exercise, not a marketing stunt. Something fundamental, the kind of advance that changes what is possible rather than what is fashionable. And Tesla has the appetite for exactly that. The company raised its spending plans to more than $25 billion, with Musk pouring money into artificial intelligence, robotics, and chips. The only question was where the next undeniable breakthrough would actually come from. It came from a quiet engineering bay, far from the Cybertruck headlines, where the next chapter was already spinning to life. It was a motor, and it was about to break a rule the entire industry treated as law. Before we get into how they pulled it off, do me a quick favor. If you enjoy these deep dives into the technology quietly reshaping our future, tap subscribe and turn on notifications so the next breakdown lands in your feed the moment it drops. It genuinely keeps stories like this one coming. Now, back to the motor, because how Tesla built it is even stranger than why.
I mean, already there's so much compute that we outsource. Our memories are stored in our phones and computers with the pictures and video.
Breaking the rules. To understand why this motor sent a chill through the industry, you first have to accept one harsh truth about electric vehicle engineering. The laws of physics are brutally hard to beat, and for a long time, the whole industry simply surrendered to them. Car makers everywhere believed they were trapped by a painful compromise. An electric car could be blisteringly fast and powerful, or it could be efficient and travel a long way on a single charge. Build a higher performance car, and it grew heavy, overheated fast, wasted energy, and demanded massive cooling just to survive. Build for efficiency instead, and it felt tame, missing the acceleration drivers craved. Most companies decided physics had drawn the line, so they stopped pushing on it and optimized around the edges, calling it progress. Tesla refused to accept the line. Instead of working inside the old approach, its engineers went looking for a completely different path. And after years of research, they built one of the most advanced electric drive units ever placed in a consumer vehicle. At the center of it sat something that sounds simple, but is fiendishly hard to perfect. A carbon fiber wrapped rotor. That was the small thing on the bench. That was what stopped Sandy Munro cold. When he cut the drive unit open and turned it under the shop lights, the detail wrapped around the spinning core was a sleeve of carbon fiber. And the moment he understood what it was doing, you could see it land on his face, because he knew exactly how hard it is to pull off. Here is why it matters. Inside, every electric motor is a spinning component called the rotor, and during operation it spins at staggering speeds. As the speed climbs, the forces inside turn savage. The faster it goes, the more the rotor behaves like it is trying to rip itself apart from the inside. Most traditional rotors physically cannot survive that. They warp, they fly apart, they cook themselves into scrap. Tesla found a way around it by wrapping the rotor in carbon fiber, a material famous for being both incredibly strong and extremely light. The wrap acts like armor, holding the rotor together under enormous stress. It is the same family of material trusted in race cars and aerospace, applied here to one of the most punishing jobs in the entire vehicle. And it was one of the first times anyone had done it in a mass-market electric car. The result was astonishing. This carbon sleeve drive unit can spin at more than 20,000 revolutions per minute, a level almost never seen in ordinary passenger vehicles. Speeds like that usually belong to specialized industrial machines, not luxury sedans you park in a garage. 20,000 revolutions per minute in a car you can use to drive your kids to school. But raw speed was not the real breakthrough. What made the design revolutionary was the control and stability it held at those extreme speeds. The carbon wrap tamed vibration and kept the rotor balanced. That steadiness sharpened its magnetic performance, letting more electrical energy turn into actual motion instead of bleeding away as heat. That is the part that quietly destroys competitors.
1,000 people, and now we got 10,000 people just in this location.
In a normal motor, a real chunk of the energy you pull from the battery is lost to heat, noise, and vibration. Tesla figured out how to claw most of it back. More of the battery moves the car, less of it gets thrown away. Same battery, more range, more speed, less heat. The benefits rewrote expectations for what an electric vehicle could be. Massive instant torque, breathtaking acceleration, high efficiency on long drives, compact, lightweight, and needing less cooling than rival systems. And that last point matters more than people realize. Cooling systems are heavy and expensive, and they steal space that could hold batteries, passengers, or cargo. A cooler running motor means less weight, fewer failure points, and more usable range from the same pack. Every other automaker has to bolt on pumps, radiators, and coolant lines just to keep their motors alive. Tesla quietly deleted that headache. The world saw the full force of this in the Tesla Model S Plaid. The Plaid uses 3 electric motors to produce more than 1,000 horsepower, and it launches from 0 to 60 miles per hour in under 2 seconds. For most of automotive history, a number like that belonged only to race cars and exotic machines worth many times the price. And the unbelievable part is what the Plaid still is underneath all that violence. A comfortable luxury sedan that can carry a family hundreds of miles on a single charge. A grocery getter that accelerates like a missile. This is the kind of result that keeps rival engineers awake. Building a fast car is one thing. Building a fast car that is also efficient, also comfortable, and also something a normal family could live with every day breaks the rule everyone agreed could not be broken. And the design itself makes copying it dangerous. Carbon fiber wrapping at production scale is a manufacturing nightmare. The carbon fiber arrives as a delicate pre-impregnated tape, and it has to be wound around the rotor under exact, unwavering tension, then cured under heat and pressure until it sets into a single rigid shell. Wind it too loose and the rotor fails at speed. Wind it too tight and the fibers crack. Miss the timing during curing and the whole part is scrap. The spin is so violent that centrifugal force alone wants to tear the rotor apart, and that carbon sleeve is the only thing holding it together. Knowing the idea is not enough. You have to do it perfectly, thousands of times, without bleeding money on scrap. A rival cannot simply photograph the part and reproduce it. They have to rebuild the entire process around it, failure by failure, eating the cost of every ruined rotor along the way. Tesla solved that before anyone else seriously tried, while the rest of the industry was still arguing about battery chemistry. That is years of pain Tesla has already paid for. Everyone else is just opening the bill. Why rivals struggle? Plenty of companies know how to build a jaw-dropping prototype. They unveil a futuristic shape, attract investors, and own the headlines for a week. But building a handful of stunning cars and producing millions of them are entirely different sports. And the second one is where most companies die.
I try to take the set of actions that are most likely to improve the probability that the future will be good.
The auto world is littered with the wreckage of brands that promise to change transportation forever, then hit catastrophe the moment real production began. Producing millions of advanced electric vehicles consistently, at prices people can afford, while still turning a profit, is a brutal and separate challenge. And it is exactly where Tesla has become one of the most feared names in the business. Tesla understood this earlier than its rivals. While other companies poured their energy into flashy designs and marketing, Tesla spent years fighting manufacturing wars behind the scenes. Production lines that did not work, robots that fought each other, bottlenecks that nearly killed the company more than once, sleeping bags on the factory floor, weeks away from running out of cash. Those ugly years are now paying off in ways the industry can no longer ignore, because the same family of drive units, the ones built around that carbon-sleeved rotor, are being engineered not just for speed or performance, but for something even more important: manufacturability. The ability to build the thing fast, cheap, and flawlessly at enormous scale. Here is the number that should make competitors sweat. Tesla wants the entire drive unit, the motor, the electronics, and the gearbox together to cost only around $1,000 to produce. $1,000. Some competitors spend 3 to 5 times that just to reach similar performance. Spread across hundreds of thousands of vehicles a year, that gap becomes the kind of margin that quietly funds entire new product lines while competitors are still trying to break even. Tesla can cut prices, win buyers, and still make money in markets where rivals lose it. And it gets worse for everyone else, because Tesla keeps cutting cost while raising performance. The company is working to strip rare earth materials out of its motors, loosening its dependence on expensive supply chains heavily tied to China, while redesigning its electronics to lean less on costly silicon carbide. The magnets inside most powerful electric motors rely on elements like neodymium and dysprosium, and refining those elements is dominated by a small handful of suppliers concentrated largely in one country. That hands a single government real leverage over the cost and even the availability of motors built anywhere on Earth. Prices can swing overnight on a policy announcement. Every automaker leaning on those magnets is, in a quiet way, building its cars on someone else's permission. If Tesla designs a competitive motor that needs far less of that material, it does not just save money. It steps partly outside that whole web of leverage while its rivals stay tangled in it. Meanwhile, the competition is bleeding. Ford Motor Company built genuinely impressive electric vehicles like the Mustang Mach-E and the F-150 Lightning, and still lost enormous amounts of money on its electric vehicle division. Think about that. Ford has built cars for over a century. They know trucks, they know scale, and they were still losing money on every electric vehicle they shipped. Lucid Motors built luxury electric cars packed with advanced technology and kept burning cash at an alarming rate. Rivian Automotive drew huge attention and investment, yet its production costs stayed painfully high. Even giants like General Motors and Volkswagen Group have hit delays, software problems, and growing worries about profitability. This is what catching up to Tesla actually looks like from the inside. It is not glamorous, it is not winning. It is mostly losing money slightly slower than the company beside you. Among global rivals, only BYD looks capable of challenging Tesla at massive scale, especially in lower-cost markets. But BYD's power comes mainly from affordability, from flooding the market with inexpensive cars. Tesla is chasing something bigger. It is trying to build the most advanced and desirable electric vehicles on Earth, while also making them cheap to produce. Cheap is one thing. Cheap, fast, efficient, and aspirational all at once is something almost no one else can promise. And this is where the story takes a strange turn. Because most people still think Tesla is a car company. And that assumption may be the most expensive mistake the entire auto industry has ever made.
Population estimates from the UN that need to be updated because they just don't make any sense. Really, you can just look at, say, what was the birth rate last year.
The hidden empire. Tesla's real strength is that it has fused several industries into one self-reinforcing machine, and the carbon sleeve drive unit sits right at the center of it, feeding everything else. Here is that loop, stated plainly once, because everything that follows is only a consequence of it. A cheaper motor means cheaper cars. Cheaper cars mean more buyers. More buyers mean more cars on the road. More cars mean more real-world driving data. More data trains smarter self-driving systems. And smarter systems make every Tesla more valuable, which funds the next, even better motor. That is the entire engine of the company in one breath. Keep it in mind, because each piece below is just one more turn of that same wheel. Start with the data. Tesla has stockpiled more real-world driving data than almost any rival on the planet. And the reason traces straight back to the motor. A cheaper, more efficient, harder to copy. Drive unit puts more Teslas on more roads, and every one of them is a rolling sensor. Rivals cannot buy that overnight. They would need years of desirable cars on the road just to begin. Then there is the battery. Tesla poured billions into making its own, because batteries are the single most expensive part of an electric car. Its 4 680 battery cells aim to raise energy density, cut cost, and simplify manufacturing. Most competitors still lean on outside suppliers, paying someone else's markup on the priciest component in every car they sell. Tesla designs the battery and the car around each other from the very first sketch, tuned for exactly what that carbon sleeve motor demands. Rivals who buy their cells wait on a partner's roadmap and pay a partner's price. Tesla sets its own. The factories tell the same story. Plants in Fremont, Shanghai, Berlin, and Austin form a fast-expanding global network, with Gigafactory Berlin being pushed toward high-volume cell production, and future sites planned in places like Mexico and potentially India could lower costs further while opening massive new markets. Every one of those factories is being tooled to build that $1,000 drive unit at scale. The motor is not a lab curiosity. It is being woven directly into Tesla's global production machine. Even the charging network is downstream of the motor. For years, critics dismissed Tesla's superchargers as a nice perk. They were wrong. More motors meant more Teslas. And more Teslas justified the most reliable charging network on the road, fast and widespread, while rival networks meant broken equipment and dead screens. Eventually, the competition surrendered. Ford and General Motors adopted Tesla's charging standard so their own customers could plug into Tesla's network. Tesla's rivals now depend on Tesla's infrastructure to keep their own customers happy. And Tesla profits every time a rival car draws power from one of its stalls. That is not ordinary competition. That is rivals paying tolls on a road the motor paid to build. So the motor sells more Teslas. The Teslas feed the data. The data feeds the artificial intelligence. And somewhere in a server room most people have never heard of, all of it is being turned into something that should scare competitors more than any single motor ever could. Where this heads, the clearest sign of where this is going is Tesla's Dojo supercomputer, built specifically to train artificial intelligence on the flood of driving video those motors put on the road. The more cars Tesla sells, the more its systems learn. The carbon-sleeved drive unit makes more cars possible. Dojo turns those cars into intelligence. It is the same wheel from a moment ago, just spinning one turn further out. And here is the gap that should keep rivals awake. Most of them rent their advantage. They lease computing power from outside providers, whether that is chips from companies like Nvidia or cloud services from Amazon, Google, and Microsoft. Tesla chose to build much of its own computing instead, because it believes its future depends less on the cars it sells today, and more on the intelligence those cars can run tomorrow. Every other automaker chasing this has to rent the compute, rent the data, and somehow build the cars too. Tesla is doing all three under one roof, and the cars come from a motor nobody else can cheaply copy. So, the competition is no longer just about building cars. Tesla is fighting across many layers at once. Battery technology, software, manufacturing, artificial intelligence, real-world data, charging networks, global scale. Catching up in even one of those would take rivals years, and every one of those layers traces back to the same place: the motor, the unglamorous piece of hardware that stopped Sandy Munro cold at his bench. Picture every executive at Ford, General Motors, Volkswagen Group, Toyota Motor Corporation, Lucid Motors, and Rivian Automotive studying that same teardown. The ones who truly understand what they are seeing probably are not sleeping, because they have realized they are not behind on one product. They are behind on the foundation every future product will be built on top of. You cannot buy your way out of that overnight. You cannot patent your way around it. You can only try to build something equivalent from scratch, while Tesla already has a decade of practice and the factories ready to print the result. By the time you arrive, the target has moved again. So, the electric vehicle revolution is real, but it may not look like what anyone expected. Instead of a balanced field of equal players, what may be forming is a world shaped by one company moving faster, learning quicker, and building a deeply connected system the rest are still struggling to understand. The motor was never the announcement, it was the signal. So, what do you think? Is this motor really the moment the electric vehicle war ends, or is the competition far from finished? Could another company actually catch Tesla in the next 10 years, or has the gap simply grown too wide to close? Drop your honest take in the comments, because the best debates always come from this community. If you made it this far, hit that like button so more people get to see this breakdown, and subscribe if you have not already. There is a lot more coming on the companies and technologies quietly reshaping the world, and you do not want to miss what is next.